Hi everyone. In the previous class we have learned how does the self-inductance take place when two coils are, when a current is flowing through a coil. And in this session we are going to discuss that how a coil, current carrying coil, can produce an induced EMF on the other coil. Here, consider a coil which is connected to a battery. And an electric current I1 is flowing through this conductor. And when this electric current I is flowing through this conductor, it produces a magnetic field B1 on the coil. And another coil is placed nearby this one coil, and which is connected to a galvanometer. And this galvanometer is used to measure the induced current produced by the second coil. And assume that this is coil is P and this coil S, and the number of turns, the total number of turns in this coil, first coil is taken as N1 and second coil is taken as N2. When an electric current I1 flows through this coil P, then a magnetic field B1 is produced, and this B1 is linked with the second coil, yes, and due to the linkage of this magnetic field produced by the first coil, produce a flux on the second coil, yes. And this magnetic flux associated with the second coil depends on the amount of electric current flowing through it. So if there is any variation in the flow of electric current, either it decreases or increases, then there will be a change in the magnetic field, and this change in the magnetic field then produces an induced EMF in the second coil. And how does it affects? And the phenomenon of production of EMF or induced current in a coil by a current flowing in a neighboring coil is known as mutual induction. And here the magnetic flux associated with the second coil, then that is phi B. Then the magnetic flux is phi B, and the phi magnetic flux on the second coil due to the first. And the N1, N2 is the number of turns, total number of turns of the second coil, and this is proportional to the current flowing through the first coil. We can say N2 phi 2 1 is equal to, and instead of this proportionality sign we can write a M21 into I1. Where what is the M21? M21 is the mutual inductance of coil 2 with respect to the coil 1. Now we can write M21, that is equal to N2 into phi 21 divided by I1. And similarly, and the second coil is connected to a battery and allows a electric current I2 is flowing through the current to the coil, and a galvanometer is connected to the first coil. Then what will happen? The flow of electric current through the second coil will produce a magnetic field B2 here, B2 here, and the magnetic field produced here produce a magnetic flux on the second coil. And when this magnetic flux is linked to the second coil, then if there is any change in this magnetic field, produce an induced EMF in the second coil. And then we can write the magnetic flux associated in the first coil N1 into phi 1 2, that is equal to, is proportional to the electric current flowing through the second coil. Or we can write N1 into phi 1 2 is equal to M12 into I2. Therefore, M12 is equal to N1 phi 12 divided by I2. And by symmetry, we can write M12 is equal to M21, that is equal to M, that is the mutual inductance. So the M is the mutual inductance of a given pair of coils and is also known as the coefficient of mutual inductance. The mutual inductance of a given pair of coils can be defined as is the magnetic flux associated with the given pair of coils when a unit current is flowing through the another coil. The current flowing through the coil may change due to some external causes. Then there will be a change in the current, and that change in the current may produce a change in the magnetic flux. If there is any change in the magnetic flux, for example, the current flowing through the coil 2 produces a magnetic field, and that magnetic field is linked with the second coil produces a magnetic flux, and if there is any change in the magnetic flux, produce an induced EMF. Then we can write this equation M21 is equal to, then we can write as dI1 divided by dt, that is rate of change of current flowing through the circuit, and that is equal to N N2 into d phi 21 divided by dt. As per Faraday's law of electromagnetic induction, and this is the magnitude of the induced EMF produced on the second coil with respect to the first coil. This can be written as epsilon, the induced current produced in second coil E2 is incorporated with the negative sign M2 dI1 divided by dt, and the induced current produced in the first coil minus M12 into dI2 divided by dt. And as per the equation, M12 is equal to M21 is equal to M, that is the mutual inductance, and these two equations can be rewritten as induced current produced in the second coil is equal to minus M divided by dI1 divided by dt, and induced current produced in the first coil EMF 1 is equal to minus M into dI2 divided by dt. So therefore M is equal to the mutual inductance, M is equal to times of this current produced, induced current produced, that is the magnitude of induced EMF produced in the magnitude of induced EMF produced in the coil 2 divided by d I divided by dt, and mutual inductance produced in the second coil, the first coil, that is the magnitude of first coil divided by d I2 divided by